Hello students, welcome to my class, and I know it's after a long time. Today's video is again on mathematics, and the topic is, I think you have already understood seeing the pictures on the board. The topic is circles. Because I am going to teach one theorem that is in 10th standard SSLC. There are two theorems on circles, but I thought before going to theorems, I must give you some basic knowledge of circles, which is very important. And this video is useful for 8th, 9th and 10th standard students. 8th and 9th standard students also need to understand this, must have this knowledge before entering into SSLC about circles. So our topic is circles. Let's start with circles. I think you have already studied circles in your lower classes, 6th and 7th standard. Circle, the definition of circle is a set of points. There are so many indefinite number of points on this line, right? This is a curved line. Of course, circle is a curved line, not straight. So there are indefinite number of points on the circle. So these indefinite number of points, set of points, they are at equal distance. They are at the same distance from a fixed point, and that fixed point is called center. We all know this. Therefore, the definition of circle becomes a set of points. A set of points. Circle is a set of points, indefinite number of points, infinite number of points. So many are there, we cannot even count. So those points are on this circle. They are on this circle. So a set of points which are at equal distance, same distance from a fixed point. They are all this. There is a point here. 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 There is a point very close to this point, right? All these points, they are at equal distance from this fixed point, and this fixed point is called center. So this is the center. Usually, center of a circle is denoted by O. O letter is used for the center. You can take other also, no problem. So circle is a set of points, indefinite number of points, infinite number of points are there on the circle, and they are all those points are at the same distance from this fixed point called center. So this is the definition of circle. Circle is a set of points which are at equal distance from a fixed point called center. Right? Now, definition of circle is over. Now we have so many parts of circle. There are so many definitions related to circles, connected with circles. Right? And the very first definition that comes to our mind when we think of a circle, that is radius. Radius, right? You have understood. You have already learned this, right? Radius. And the plural is radii. Radius is singular. Radii, R-A-D-I-I, radii is plural of radius. Right? Now, what is this radius? Radius is distance from center to the circumference. Distance from center to the circumference. Now question comes, what does circumference mean? Circumference, this curved line, this circle boundary of the circle, this curved line is called, this is called circumference. This boundary is circumference. So this distance from center to the circumference is called radius of the circle. So if anyone asks you what is the definition of radius, radius is distance from center to circumference. Distance from center to circumference. This distance, that may be 2 centimeter, or that may be 3 centimeter, or that may be 10 centimeter, or that may be 1 kilometer, right? So the distance from center to the circumference, this distance is called radius, and the plural is radii. Now question comes, this is a very common question that may come in exam. How many radii can be drawn in a circle? I have already drawn one radius. This is one radius. I can draw one more, or I can draw one more, or I can draw this. They are all, and one more important thing, all radii in a circle are equal in length. If this radius is 2 centimeter, this will also be 2 centimeter, this will also be 2 centimeter, this will also be 2 centimeter. If I draw a here, it will also be 2 centimeters. Right? Now, how many are like this possible? We all know that radius is distance, a line, or the distance joining from center to one point of the circle, right? Now, how many points are there on the circle? We all know that there are indefinite number of points, infinite number of points, uncountable number of points on the circle. So, if I join them all, then number of radii will also be indefinite, will be infinite, will be uncountable. So, in a circle, indefinite number of radii can be drawn. Indefinite or infinite number of or uncountable number of radii can be drawn in a circle, and all the radii of a circle are equal in length. If you draw a circle and draw one radius, if that is 5 centimeter, then all the radii in that circle will be equal to 5 centimeter only. Right, now this is clear. This is all about radius, and we have already seen, I have shown you center. Center is a fixed point which is at equal distance from all the points of the circle, right? A fixed point which is at equal distance from all the points on the circle. Center, we have seen that this boundary is called circumference of the circle, or you can say the length of the boundary is circumference of the circle. And then radius, we have seen distance from center to the circumference. The length, line joining center to any one point on the circle is radius. You can define it this way also. A line joining center to any one point on the circle is called radius, or distance from center to circumference is also called radius. Now let's see another important thing. What if I join 2 points on the circle? Here I am joining for radius, only one point on the circle is connected to, joined to center. What if I join 2 points on the circle? These are 2 points on the circle. Here is a point and here is another point. 2 points on the circle are joined. What about this line? This line is called chord. We call it chord. Line joining any 2 points on the circle. Line joining any 2 points on the circle is called chord. And observe that this chord is far from center, right? What if I draw another chord which is closer than this to the center? Let's see. I have drawn another chord. This is one more chord. Why am I calling it chord? Because chord is a line which joins 2 points on the circle, and this line is joining 2 points on the circle, right? Here is a point and here is one more point. I'm joining them. So it's a chord, right? Now what about the difference between these two chords? This chord is longer than this. This is longer than this, right? Now, what if I draw here? This is longer than this one, right? The length is increasing. Observe carefully. As I am going close to center, the length of the chord is increasing. Now what if I draw a chord that passes through the center? What if I draw a chord that passes through the center? This chord is passing through the center. Imagine this is AB, this chord is PQ, this chord is XY, this chord is MN. So MN chord, these are all chords. AB is a chord, PQ is a chord, XY is a chord, MN is also a chord. These are chords, but these chords AB, PQ and XY are not passing through center. This chord is special. It's passing through the center. And one more thing is there. This is the longest. Why? Because if I draw a chord below this, again going away from center, the length will decrease. Here the length was increasing, increased and became the longest. Here again the length will decrease. So as we go away from the center, the length of the chord decreases. And as we go closer to center, the length of chord increases, and a chord that passes through the center, that is the longest chord, and that chord has a special name called diameter. We call it diameter. This chord MN is diameter. MN is diameter. What about XY? XY is not diameter. It's just a chord. What about PQ? PQ is just a chord. AB is also just a chord. But MN, it is a chord as well as diameter because it is passing through the center. So we can say like this, the definition of diameter is chord which passes through the center. The longest chord which passes through the center is called diameter, and it is the longest one, right? Now if you observe carefully, imagine this center is again O. Center is O. What about OM? OM is radius, we know. What about OM? OM is also radius. So two radii give us one diameter. Two radii give us one diameter. That means diameter is double the radius. Diameter is double the radius. Diameter is always twice the radius. And what about radius? Radius is half of, in maths, multiplication is off is multiplication, half of diameter. You have to remember this. These are important results, right? Now, diameter is also over. We have seen these things. Radius, we saw the definition of circle, we saw the definition of center, we saw the definition of radius, we saw how many radii can be drawn, infinite number of radii can be drawn, and we also saw that all the radii of a circle are equal in length. What about all the diameter? Now how many diameter can be drawn? How many diameters can be drawn in a circle? Again infinite. I have drawn, this is a diameter. I can draw a diameter like this. I can draw like this. I can draw like this. So many. So indefinite number of diameters are possible. Diameters are also indefinite. Infinite number of uncountable number of diameters can be drawn in a circle. Right? Just like infinite number of indefinite number of radii can be drawn, in the same way indefinite number of diameters can be drawn in a circle. Right? Okay. Now let's move on to another thing related to circles. Some more things are there, right? Okay. Now here is, I'm drawing a card. Here is a card. This is a card, right? We have center here. This is a card, right? We have a card here. Imagine this card is suppose CD. CD is a chord, right? This chord is making two parts of the circle. We have a part here, circle, and we have here, right? Okay. What about this part? Of course, it is smaller in area. This region is smaller in area, and this region is of course bigger. This region is bigger. This region is bigger. This region is bigger. This region bounded by a chord and an arc. Arc is a piece of circle. For example, from this circumference, if I take this much, then this much is arc. When we take a small piece of circumference of a circle, that small piece is called, a piece of circumference of a circle is called arc. Now we have an arc here. This is the arc. This is an arc. This is an arc. This is an arc. So, and this is a chord. The area or region bounded by a chord and an arc, region bounded by a chord and an arc is called segment. Now this side also we have an arc. This side also we have an arc. And we know that this arc is smaller and this arc is bigger. So this arc is called minor arc and this arc is called major arc. Minor arc, smaller one, major arc, bigger one. So the region bounded by a chord and minor arc, it is called minor segment. This is minor segment. How about this one? How about this? This is major segment. Major segment. Region bounded by a chord and major arc. This arc is major. This region is called major segment. And the segment which is bounded by a chord and minor arc is called minor segment. This is very important. You have to remember it. Right? Okay, now let's move on to another important thing here. Let me draw some things here. We have arc here. We have a if you join this point to this point and this here, then obtuse angle will be formed. Obtuse angle. So you have to remember, angle formed in minor segment is obtuse. Is always obtuse. Angle formed in minor segment. What if I draw an angle here? This will be here. Here is an angle. This angle is acute angle, less than 90. This is obtuse, more than 90. This is acute, less than 90. So you can write this. Angle formed in major segment is always acute. Acute means less than 90 degree. You know acute angle, right? Acute angle less than 90 degree. Obtuse angle more than 90 degree. This thing you have to remember about major segment and minor segment. What if angle is formed in a semicircle? Semicircle, the word itself says semicircle. Semicircle is half the circle, right? Half the circle. Semicircle. What if angle is drawn here? This angle will be definitely equal to 90 degree. Angle formed in a semicircle is always right angle. Right angle, that means 90 degree. Right? If you draw a circle, a semicircle, and you draw an angle here, this angle will be definitely equal to, this angle will be definitely equal to 90 degrees, right? If you draw here, for example, if you draw here, this is the center, right? Now this is the semicircle, this is semicircle, right? Semicircle, this is semicircle, this is semicircle, right? Half of the circle, semicircle, half of the circle. A diameter divides the circle into two equal parts. Each part is semicircle. If you draw an angle here, that angle will be definitely equal to 90 degrees. So angle formed in minor segment is always more than 90. Angle formed in major segment is always less than 90. And angle formed in a semicircle is always right angle, equal to 90 degrees. Right? Now, this was all about circles. And some more things are there, which we have to discuss. And I want to tell you that if you take we all know that area of circle is equal to pi r square, and circumference of a circle is always equal to 2 pi r. Circumference is always 2 pi r. Okay, now if this is the circumference, right? Circumference of a circle is always equal to 2 pi r. Now, circumference can be written as c. Let's give c for circumference is equal to this pi, keep it as it is, and we have 2r here. 2 into r, right? 2 into r is equal to diameter, right? 2 into radius is always equal to diameter. So this 2 into r, I can write it as d. Or I can write c divided by d is equal to pi. Or I can write c divided by d is equal to 22 divided by 7. Pi is 22 divided by 7. We all know that pi is a constant number. It's 22 divided by 7. Now, what does it mean? It means if you divide circumference of any circle by its diameter, divide circumference of any circle by its diameter of the same circle, then that will always be equal to pi. That will be 22 divided by 7. I think maybe this is how the pi was invented, right? This is how the pi was discovered. Pi 22 divided by 7. This may be one way to find pi. I think what would happen in the past, maybe someone noticed that, maybe a mathematician noticed that whenever circumference of a circle, whenever circumference is divided by diameter of any circle, then it is always giving 22 divided by 7. So that is a fixed number for a big circle, for a medium circle, for a small circle, for any circle, if you divide circumference by the diameter of that same circle, that will always give you 22 divided by 7. Now question comes, how they found circumference, right? Circumference, we know formula is there, 2 pi r. If pi was not there, imagine pi was not yet discovered, then how they found circumference? It's very easy. Take a thread and put it all over the circle. Take a piece of thread, starting from here, thread goes like this, and comes back to the same point, and take that thread and measure its length. Whatever is the length of the thread, same is the length of the circle, that is the circumference, right? In this way, they form circumference. And how about diameter? Imagine a circle is drawn and take a thread or something, or just find this distance from center to circumference and double it. That will give you the diameter. And then that circumference was divided by the diameter. It gave 22 divided by 7. And the same thing done for another circle. Again, circumference divided by diameter gave 22 divided by 7. Another circle was taken, and then again that circumference using thread, circumference was measured, and then divided by diameter, again 22 divided by 7 came. So in this way we can say that maybe this is how pi was discovered. 22 by 7 was discovered, or maybe some other thing also must be there. Now this is how we saw so many things about circles, right? Some more things are there related to circles. I would like to discuss those in another video. I don't want the video to be very long. I want you to watch short videos and learn these things at home. Remaining things will be discussed in another video. Thank you. Watch my video repeatedly, like it, share with your friends, and do not forget to subscribe the channel Amar Sir on YouTube. Thank you.